Hello, everybody. Welcome to our session on achieving new levels of cloud performance and security with AMD and Azure. We're so pleased to have you here, and we've brought a number of guests with us from the Azure and AMD sides, from the product teams and engineering teams. So today's conversation is going to be interactive, so please ask any questions you may about our joint offerings in Azure with AMD EPYC's 3rd gen processors. So we've got the product teams from the Azure HBC, Azure Compute, and Azure Security, as well as experts from the AMD engineering team. They're going to be talking about some of the capabilities and new announcements from their respective products. And so I'm going to go ahead and pass it over to Evan Burness to kick us off on the Azure HPC side.
You're on mute, Evan.
There we go. Thank you, Sean. And thank you for inviting me to speak with you all today about how we in the Azure High Performance Computing team use AMD EPYC 3rd gen processors to support a variety of Azure customer HPC scenarios. Azure was very early to adopt AMD EPYC processors for high performance computing scenarios. In fact, we released our 3rd gen Azure HB Series virtual machines on the same day that AMD unveiled Milan processors to the world earlier this year. What's exciting about this VM product here in Azure is that it is by far our highest performance, most scalable, and most cost-effective HPC virtual machine we've ever released. And in addition, it offers much greater sort of choice and flexibility for customers. These VMs feature up to 120 physical AMD EPYC 3rd gen processor cores, industry-leading 350 gigabytes per second of memory bandwidth. We are and remain the only public cloud provider with InfiniBand networking. We offer 200 gigabit HDR InfiniBand networking, as well as local NVMe storage. And we have a broad variety of consumption models for our customers to choose from, both directly as IaaS consumption, where customers spin up VMs directly, or by using these VMs through one of Azure's many software as a service partners, or partners such as Ansys Cloud or Rescale. People often ask me, what is the difference with these machines? What actually makes them well suited for high performance computing scenarios? We do a number of things with this particular product that really shows just how focused it is at the needs of HPC customers. To start, we do not support any level of VM multi-tenancy on these virtual machines. This means that when a customer deploys a virtual machine against HBV3 series, that virtual machine has exclusive access to the underlying physical server. There's no contention for resources with any customers. The second thing is we do direct, accurate mapping of the hardware at the bare metal layer into the virtual machine. So our high performance computing customers don't have to wonder whether the topology they see within the VM is an abstraction of the true underlying topology. The third thing we do is we use industry standard and open OFED drivers for the InfiniBand networking, meaning that customers can use the InfiniBand just like they do in on-premises deployments or at supercomputing centers around the planet. And then the last thing I would really call attention to is we do a lot of work with the AMD team specifically in order to tune and optimize our BIOS configuration to really support the needs of high performance computing customers. This goes as deep as the fact that we disable simultaneous multi-threading, to how we tune C states for optimal power delivery to give customers higher per core frequency when they need it. And this is really a reflection of the great engineering partnership we have with AMD in support of our HPC customers. But aside from the technical details, what really matters is the actual impact to customers and what this translates into. And everything what I've really just described really comes down to much higher levels of performance than what you'd find on any other public cloud provider's virtual machine, and just as high as, frankly, as the leading CPU-based servers on any of the top supercomputers in the world. You see highly consistent performance because you're not contending for resources with any other customers, and you get to engage and use this technology just like you would in a bare metal on-premise installation. So customers coming from an on-premises deployment have a very familiar runway in terms of adopting Azure in support of their HPC workloads. One really great thing that we want to support for our customers, and we hear all the time that this amounts to a significant level of differentiation, is we want to help customers scale their applications significantly higher and faster than they are able to do on premises, or that their engineers and scientists are currently able to solve their simulations. So what I'm really demonstrating here is the terrific complementarity between EPYC 3rd Gen processors in Azure's end-to-end product design, including the use of InfiniBand networking. Here, I'm showing an example of running a highly popular weather simulation application called WRF, or WRF, as it's commonly referred to within the community. This is an application that a large percentage of stakeholders in the weather simulation community, whether they're private or government consumers of this information, they really rely on the output of this application in order to understand how what standard or even significant and severe weather events are going to impact their communities. What we're showing you here in the graph is the fact that on Azure, on the HBV3 virtual machines, customers can scale their applications with very high levels of efficiency. In other words, what you're seeing here is going from one virtual machine of the HBV3 series all the way to 32, we're actually delivering a 36x speed up. So for every incremental virtual machine the customer adds, they're getting a corresponding speed up. That's very difficult to deliver in a high performance computing environment, that one-for-one relationship. But you'll notice that even at 32 virtual machines, it would be great if we could deliver a 32x speed up, but in fact, we're delivering a 36x speed up. What that also means, as a consequence of delivering more in terms of the return on the investment of additional virtual machines, is that the actual compute cost goes down. So our customers in this particular simulation solve the problem 36 times faster for only 88% of the cost that they would if they were using a significant virtual machine. And again, this really goes to the theme of what we try to deliver with our to our customers and as part of our partnership with AMD, which is we want to help our customers get smarter at what they do with the scale that's available to them on the Azure cloud. And with that, I'll turn it over to my colleague, Brenda Bell.
Hey, thank you, Evan. I'm Brenda Bell, Program Manager of the Azure Core Compute Platform team. So today, guess the next slide, if you don't mind, Sean. Great. Today, I'm excited to introduce you with the two new virtual machine series, and they are general purpose and a memory optimized VM family. So this new VM family based on the latest AMD EPYC Milan processor. And this processor run at the base speed of 2.55 gigahertz and then can achieve maximum frequency of the 3.7 gigahertz. This new VM series come in two flavors, with one with a local temp disk called the DAD SV5 or EAD SV5, and one without the actual local temp disk, which is the DA SV5 and the EA SV5. And we'll talk a little bit more about that, what that means on the VM sizes next. So this new VM series come with the two flavor. We actually continue offer the ability to attach this standard HDD and or standard or premium SSD and ultra SSD in just like our previous generations. And we're also excited to let you know that nested virtualization is now available on these VMs. Nested virtualization is a feature that basically allows you to create VM inside a VM. This nested environment gives you a flexibility in supporting your needs in various environments or area, kind of like development, testing, training, or demo, etc. We also have reserved instance, the RI, and spot pricing and AKS, Azure Kubernetes Service available on these VM sizes as well. So as you recall in the previous generation, sorry, last slide. You want to go back two slide? This one. Thank you. So you recall that in our previous generation that our VMs, example like a DAS v4, the VMs had come with the local temp disk. And you can see that here in the D drive. This temp disk, they're not persist, but the drive could use for different purposes, like the OS page files and or temp DB on the databases or they are using for the disk cache. What is exciting about the new DAS v5 and the EADS v5 sizes, they now offer more SSD capacity, actually up to 50% more larger capacity compared with our v4 versions. And if you need more SSD capacity, this is great VM for you to use. And with the new VM that have no local temp disk, which is on your right-hand side of the slide, called the DAS v5 or the EAS v5 offering, you can't see the actual temp disk anymore, which means the D drive. But the OS page file has moved to the OS disk, so they still allow you to continue to deploy your Windows images without any issue. So if you don't need any local temp disk, you now can enjoy a lower price point if these VM sizes meet your need. And one key important point in here is that the both VM offering will give you the ability to attach the remote disk for persistent storage. So the options are listed here, the standard HDD, premium SSD and HDD, or ultra SSD. Next, please. Thank you. So the naming can be confusing. So let's put that on the table side by side. The old VMs that have the default local temp disk attached, and now that you have two new options to choose from. If you don't need the local temp disk, then you can take the advantage of the low cost option, which is your DAS v5. Yes, that is the same name as the old one, so it can be confusing at first. And then the new DAS v5, that with the little d letter in the naming, mean disk. So that actually have the local disk attached. So to recap, DAS v5 with no local disk and DAS v5 with local disk. Same thing for the E series. So are we all clear? So hopefully this table is actually give you a little bit more on what is the actual old size mean and then a new offering that we have today. Next, please. So let's take a look at the actual chart and compare with our V4 and V5 version side by side. And you can see that the new VM sizes offer 50% larger local storage and more SSD capacity for you to use now. And then you can, and we also increase the actual local disk IOPS, temp disk IOPS, and the throughput as well. So in the chart on the right, you can see the much faster on both read and write operation compared with our previous version of the VM sizes. So for those that you're looking for more SSD capacity and a faster local disk IOPS, please give those new VM a try and take a look on how that meet your actual workload needs. And now that I would like to pass on to my colleague, Graham, who is going to tell you a bit more about the Azure confidential computing space. Thank you.
Thanks a lot, Brenda. Hi, folks. My name is Graham Bury. I'm a product manager for the Azure confidential computing team. Since confidential computing is still relatively new industry-wide in terms of exposure and understanding, I'll spend a couple minutes to talk about confidential computing. Well, we've seen various reasons that introduce needs for confidential computing. This has been led with high interest from regulated industries like finance, healthcare, government sectors, where there's quite sensitive data desired to move to the cloud. And where the power of cloud processing comes in, you can innovate and make new experiences with new insights on this data. So that gets us into what confidential computing entails and what we have to offer from Azure. I'll go over that here. So from a security perspective, Azure is a very secure cloud with policies and safeguards to protect your data while it runs in Azure. Additionally, over the last several years, we've been investing in technologies to bring further protection to this data and add defense in depth right down to the silicon that's running and processing your data. In a desire to protect your data end to end, this is building upon solutions that we already have for protecting your data while at rest and in transit with either disk encryption or network encryption. This is where we're investing so that data can be protected even while it's in use and processing in the CPUs and memory, so that we can then protect your data through its entire life cycle. We're also pushing this level of protection to be pervasive within Microsoft as well as across the industry. If you remember 15 years ago, the internet traffic on websites was always being sent in the clear with HTTP. And then this transition went to say, hey, now all internet traffic is HTTPS and encrypted. We see the same thing happening in the compute space, especially in the cloud. So this is our vision that within Azure, we aim to move to a confidential cloud where all data can be processed confidentially, both in the cloud and on the edge. And we're in the beginning stages of that journey. So let's understand where we are on this journey and what does it mean to bring confidential computing into Azure. We start by partnering with our hardware vendors like AMD so that we can have the latest innovations for in-memory data protection. These partnerships also enable us to provide infrastructure where we have a hardware root of trust outside of Microsoft. So you can verify that the hardware configuration hasn't been tampered with and that your data is only processed once the environment is verified. And one of our mechanisms to do that is with remote attestation. The technology can provide strong isolation between tenants and provide memory encryption as well to give protection against risks of any host and hypervisor access or cross-tenant malicious applications. If there is tampering, even an admin or someone with physical access wouldn't be able to do, say, a memory dump and see that data unencrypted. It remains in this black box for where it's processing. We're working to bring these confidential computing capabilities across all of our infrastructure and services, like with containers in AKS, so that you can cater to your different needs, leverage the services that you want to use. We have offerings that go from easy lift and shift type migrations and deployments to increasing levels of security control, where even you can put control right down to the application level, so that you only need to trust the specific code that accesses your data, which you would own. We're also working higher levels in the stack to bring confidential capabilities through our Azure services. For example, we have SQL Always Encrypted, where we can protect data from even database admins, so that a database admin couldn't see into queries or the results from a query for anything that accesses that data from the database. Or our confidential ledger service. This is for a secure blockchain tamper-proof logging capabilities based on some of our open source frameworks that run on confidential compute. Confidential computing offerings can be a critical tool in building and deploying solutions with a zero trust architecture. This is where you assume breach for various components, and we have offerings that can help secure your data against various aspects that could compromise your data. So with that, I'm excited to share that coming this month, we have our new AMD EPYC-based VMs that leverage AMD SEV SMP technologies. So Sean, if you want to transition the slide here. This is where we have protection across the entire VM so that you can seamlessly move a workload from being a workload to Azure with these confidential capabilities. We also will have these VMs exposed through AKS, so as worker nodes, so that you can leverage that same SEV SMP memory encryption with your container-based applications and workloads. The specs for these VMs are the exact same that Brenda just went over from a general compute perspective. These just have the SEV SMP memory encryption capabilities and some other aspects that we support within Azure. Very happy to go into some of those details and in a follow-up session that we have to this one that I believe is coming.
Excellent. So maybe we can move to Lax.
Yeah, hey, as you heard from Graham, we will have amazing session coming up at 1:30. Don't miss it. This is all about the enterprise workload performance on AMD-based VMs in Azure, and all the technology and the thinking and the partnership here with Microsoft Azure, you will get to see as proof points that you can leverage. Thanks again for your time.
Okay. And with that, we can go ahead and transition to Q&A. So if you have any questions, please add them to the chat window. I have a couple here. We can first direct to Graham. And the question is, do I have to change my code to migrate to DC AS v5?
No, so from that perspective, you can bring your existing code without any modifications to run in our confidential virtual machines. The one aspect is you'll have to redeploy and later this month when the VMs are available, it'll be directly through the Azure portal. So you just pick your VM size. There's certain operating systems that are supported for confidential compute, and then you'll be able to just deploy directly onto these virtual machines. There'll be a couple steps in terms of encrypting your VM to make sure it can take advantage of all the capabilities we have from encryption and use perspective, and then you can just get up and running with all your existing code.
Excellent. All right. There's another question that came in about the performance uplift of the previous generation of general purpose VMs versus the DAS EAS v5 VMs. So maybe Lax or Brenda, if you could comment on some of the results. And I know we're talking about this in our next session as well.
Yeah, highly encouraged that we if you can have a chance to kind of go into the actual sessions, because of some of the actual benchmark results that Lex from AMD team will be showing. But we have done some optimizations on our actual new v5 sizes. So obviously the performance is dependent on the actual workload. So cannot really guarantee exactly the numbers, but it will be good for folks to actually try it out. We do see actually from a lot of the actual workload has seen the performance improvement on the new v5 sizes.
Excellent. We've got a question on, is there a pricing difference between confidential compute and non-confidential VMs?
I can cover that one. We're still getting our preview ready, and we're working on the pricing plan. There may be some differences in the pricing at first. I'm not purview to exactly what they are, but as soon as our public preview will be available later this month, then the pricing specifics will be coincide with that preview.
Excellent. Thank you. So the next question is around, I'll stay with you, Graham, if you don't mind. It's how do you seamlessly lift and shift my app and get the full memory encryption with no changes required?
So we will definitely cover this in a little bit more detail in the next session in terms of where the encryption and what level the protection is. From that point of view, the entire memory of the VM is encrypted. So what we end up doing is, as long as you have your you go to the portal, pick an OS image where we have support for the confidential capabilities. Specifically, there's Windows Server 2019, 2022, and Ubuntu 2004 and beyond. All of those OS images are enlightened to support the AMD SEV SMP capabilities. And then what will happen is you bring your workload or your VM as is, you encrypt it while it gets uploaded and initialized, and then that entire VM becomes encrypted and inaccessible in memory, so that everything within the VM is fine and trusted and operates, and then anyone outside of that VM is blocked from being able to access any of the data. So from that point of view, your workload would operate as normal, say your application code processing on the data from within this black box of the VM. So we have a couple slides and deeper explanations in the session coming up if you're interested as well.
Excellent. Okay, one more for Graham, and then we'll pass it over to Evan for the next one here. It's and I imagine this will be one we cover in the future as well, but are confidential VMs available in all regions?
In a few weeks, when we start our public preview, there'll be a couple regions that we start in, just in terms of a preview state. And then over time, we will build out to more and more regions as we deploy, getting ready for general availability. Great.
Thank you for that. And everybody, we've got a few more minutes, so please get your final questions in now, if you have any. The next one is for Evan. It's around, are there any challenges spotting the difference between AMD and Intel and making calculations using MATLAB or ANSYS? So this may just be when to use which VM for which scenario, perhaps, type of a question.
I don't think there are challenges per se between those two things. The biggest thing is if you are running an ISV application, that you understand the terms of how your ISV scales licensing costs. So for example, are you paying essentially a flat licensing fee to your ISV, and then they enable you to run that application in whatever hardware configuration that you would like? Are you paying more on a per core basis or a per VM basis? And for either of those, then how do those things scale? One thing I can tell you on the HBV3 series that we've done for the first time on the HPC side in response to customer feedback and requests is we've added Azure constrained cores VM sizes to HBV3. It's our first HPC VM that has this product. For those of you who don't know, a constrained cores size keeps global shared assets like memory bandwidth, L3 cache, InfiniBand networking, local SSD constant, but allows you, the user, to down select a smaller number of processor cores in order to both increase, say, the performance per core if you have a scenario that really needs to optimize against that. But another common usage scenario that sort of aligns with this question around MATLAB or ANSYS is if an ISV licenses on a per core basis specifically, we offer up to 120 cores in the VM, but if using all 120 cores would blow up your software licensing, but you still want to get all the memory bandwidth and all the L3 cache, you can select a much smaller number of cores to allocate all those really compelling global shared assets against, so that you can really control your total cost of solution between the VM infrastructure and the software licensing.
Excellent. All right, we are at the end of our time. So thank you so much to the experts for joining the session. And thanks to those who joined and asked questions. And this will be recorded and available for you all if you want to watch it in the future as well. And so thank you very much. And please join us in our next session. Have a great rest of your day.